In this video, I'm going to talk about how to obtain the three most important basic algebraic identities in the world. If we are given the expression x plus y all squared and we want to get rid of the parentheses, many people would write it as x squared plus y squared. However, it is entirely wrong since power cannot distribute over addition. More elaboration is given in another video, and you can access it by clicking at the link at the top right corner. The proper way to rewrite this expression without the parentheses is to think about the definition of squaring. X plus y squared is actually the same as x plus y times x plus y. And we can expand this expression by distribution, or some people would call it foiling. When we do expansion, most people would do it by x times x, and then x times y, and then we do y times x, and then y times y. Of course, this is correct, but I'm going to do it slightly differently here. I'm going to think about the power of x when I multiply, and I would try to collect those terms that share the same power of x. In this parenthesis, this term has power 1 for x, and this term has power 0 for x. Same thing for this parenthesis, power 1 and power 0. So after expansion, we know that the highest power of x is 2, coming from power 1 term times power 1 term. When we multiply these two terms, we will get x squared, and we often call this the top term as well, because this term has the highest power of x among all. Next, we are going to look for the bottom term. The bottom term is referring to the term with the lowest power of x, and it is obtained by multiplying positive y with positive y. So we have positive y squared as the bottom term. Finally, the middle term is often called the mixed term. And from the name, you can sense that it is obtained by multiplying terms with different powers of x. So here, we will multiply x with positive y to obtain positive xy, as well as positive y with x to also obtain positive xy. So we have two copies of positive xy, and we are going to combine them to form positive 2xy. How about the expression x minus y all squared? If we want to expand this and get rid of the parentheses, what we should do is to think about x minus y times x minus y. If we use the same analysis as above, then the top term will be obtained by x times x, so we have x squared. The bottom term is obtained by negative y times negative y, so we have positive y squared. As for the mixed term, it's obtained by x times negative y, as well as negative y times x. Both of them give us negative xy, so we have negative 2xy for the mixed term. What about x plus y times x minus y? When we expand this expression and get rid of the parentheses, we will get the top term as x squared because of x times x. The bottom term will be minus y squared because of positive y times negative y. As for the mixed term, we will have x times negative y, so we have negative of xy, as well as positive y times x, so we have positive xy here. Negative xy plus positive xy would cancel each other and get 0xy. So it looks like that we have no mixed term here, but actually there is, just that the coefficient is 0. To summarize, we have just obtained the three most important algebraic identities in the world. The first one is the difference of squares, which says that x plus y times x minus y is equal to a difference of two squares, x squared and y squared. The second identity is square of sum, which says that x plus y all squared is equal to x squared plus 2xy plus y squared. The third one is square of difference, which says that if we first take the difference between two numbers x and y, and then take the square, we will get x squared minus 2xy plus y squared. Please make sure that you don't mix up x squared minus y squared with x minus y all squared. This is a difference between two individual squares, while this one is a self-multiplication of the number x minus y. Between these two identities, when we change the sign, notice that the only sign change is for the mixed term. Both the square terms are positive. Now, we have finished introducing these three identities. As for the applications, please check out the next video. Thank you.